I am going to show you how to graph quadratic functions, and this is one of the easier ways. It's a little introductory. We are going to learn more about graphing quadratic functions over the next week, but this just gets us started a little bit. So I'm going to start with what is known as the parent graph, and the reason why it is called the parent graph is because this is the basic quadratic function. So there's no leading coefficient, there isn't even a b or a c. This is just a bare bones graph or basic quadratic function. So yesterday we talked about how when we graph a quadratic function we get a parabola. So this is the graph of the standard parabola. So parabola is a U-shaped, and again I mentioned that the U could go up or it could go down. What we're going to do is work off of what we learned yesterday with how we find the vertex and axis of symmetry, because that's the most important part of the parabola. Once we get that, we can easily find the rest of the parabola. So I'm going to demonstrate and show that to you through our examples. So first thing I want to do is just show you what the parent graph looks like. So to start off, I am going to do just a table of values. So if we had an XY, a t-table here, I'm just going to do 2, 1, 0, negative 1, negative 2, because those points are just right around the origin. So it's pretty basic. All right, so what's going to happen is we are going to first fill in the x. So for y equals x squared, we're going to first fill it in with a 2. So if we fill in 2 for x, y is 2 squared, which is 4. If we fill in a 1 for x, y is 1 squared, which is 1. If we fill in 0 for x, we get 0. If we fill in negative 1 for x, we get 1. If we fill in negative 2 for x, we get 4. So what we're going to do is, I'm going to grab a little graph here, and I'm going to plot these points so that you can see what a standard parabola looks like. So let me make an x and a y axis here. All right, so that marker's a little weird. All right, so I'm just going to plot these points. So 2, 4, so over 2, up 4 is a point. 1, 1, over 1, up 1 is a point. 0, 0 is a point right there. Negative 1, 1 is right here. Negative 2, 4 is right there. So you can see that I now have points to guide me, so to speak, to make my parabola, which does not come down to a point. It is just a continuous curve. But what I want to show you that is very cool, and I think it makes total sense on the parabola, so I'm going to zoom in a little bit here. Let's get focused if we can. That black is really weird. But what I want to show you is that the parabola follows what you would expect to happen when you square a number. So here our vertex is 0, 0. On the parent graph, it sits right at the origin. As we went over 1, we went up 1, because 1 squared is 1. When we went over 2, we went up 4, because 2 squared is 4. So I want you to make a guess. If we went over 3, how far do you think our graph would go up? Hopefully you're saying 9. Because 3 squared is 9. All right, now I don't have the space for this. I didn't even have the space for that one. But if we went over 4, you would expect that the ordered pair would be 4, 16. And this makes sense because we're squaring the value of x. Now, if you notice, we also mentioned that the axis of symmetry is that imaginary line. Let's see if I can make it kind of right here so you can kind of see it. The axis of symmetry is the imaginary line that runs straight through the middle of the parabola, going through the vertex, and it cuts the parabola in half. So if I went left 1, I'd go up 1. Left 2, I would go up 4. Left 3, I would go up 9. Left 4, I would go up 16, and so on. And it totally makes sense because we're squaring the number that we're moving on the x. All right, so keeping that in mind, let's move on to our first example. All right, here we go. So let's say that, let's zoom out just a little bit. For example 1, let's say y equals x squared minus 4x plus 3. All right, so thinking about what we know, this one is in standard form. In order to find the vertex when we are in standard form, we need to do negative b over 2a. So our vertex, our x value, we need to do negative b over 2a. So negative b is 4 over 2a would be 2. So that tells me that the x value is 2. Now, in order to find the y value, we just need to fill this back into the problem. So 2 squared is 4. Minus, I'm filling in a 2, so that's minus 8. And then plus 3. And for that, we're getting a negative 1. We'll just pretend there. So 2, negative 1. All right, now because of this, we know that the axis of symmetry is the vertical line that's located at x equals 2. So I'm going to grab a graph, and I don't think I want to use that marker again because that one was terrible. So I'm going to go like this and here. All right, so our vertex is located at 2, negative 1. So 2, negative 1 is the vertex. And now I'm going to tell you that the value of a right here is a 1. So what that means is that I'm just going to draw a standard size parabola. So from the vertex, if we remember what happens, a parabola is going to go over 1 and up 1 because 1 squared is 1. If I go over 2, I should go up 4 because 2 squared is 4. If I go over 3, I would go up 9, 2, 3, 4, which I don't have enough on here. All right, but then I also know that the axis of symmetry is located right here, and that's an imaginary line, so this point has a mirror image right there, and this point has a mirror image right here, so now I can sketch the parabola. So here is my parabola that has the vertex located at 2, -1. All right, let's try intercept form. So for our next example, let's see, get a different color. So example 2. All right, let's say y equals x minus 2, x minus 4. All right, so hopefully you recognize that this is intercept form. These are our two intercepts. So the way we find the vertex when we have this kind of problem is we find our two x-intercepts. So this one is 2, that one is 4. And then we're going to find the middle of those, which is basically just the average of those two. So if we, or you can even just think the middle of 2 and 4 is 3, but 2 plus 4 is 6 divided by 2. So I know that my x value is 3. So now to figure out what the y value is, I need to fill in 3 for x. So 3 minus 2 is 1. And then 3 minus 4 is -1. Multiply that, I get -1. So now I know the location of the vertex. And since I know the location of the vertex, I know that the axis of symmetry is going to go through x equals 3. So going over to the graph, again, I'm going to sketch, let's see, 3, -1. All right, that's not that much different from the last one we did. So here is a graph. All right, I'm going to start by plotting the vertex. So 3, -1, so over 3 down 1 is right here. I know that the axis of symmetry is just the imaginary line going right through there. And then again, right out in front, right here, I have a 1. So I know that this is just a normal size parabola. So if you remember, from the vertex, we're going to go over 1, up 1, over 2, up 4, over 3, up 9, except my graph isn't big enough. But now I know that these have mirror image points on this side, and then we can create our parabola just like that. All right, now, if we had an equation in vertex form, we're going to do exactly the same thing, in that we're going to find where the vertex is located, find where the axis of symmetry is located. We're going to plot the vertex and the axis of symmetry on our graph, and then using what we know about a standard parabola, over 1, up 1, because 1 squared is 1, 2 squared is 4, 3 squared is 9, and we're going to do as much as we can fit. Now my graphs here couldn't fit more than just those 5 points. If we could fit more, we would, because that gives us a better shape. Now there's more to graphing the quadratic functions. I mentioned that both of these had a leading coefficient of 1. So we're going to save that for another video, what we do when our leading coefficient is something other than a 1.